Assalamualaikum warahmatullahi wabarakatuh. So our group will present about base-catalyzed Diels-Alder reaction between two pyrone that falls under the topic of Diels-Alder reaction. This is for the course SCD4062 Industrial Catalysis. At this juncture, we would like to take this opportunity to express our sincere appreciation to Associate Prof. Dr. Sarha for her guidance, knowledge, and dedication in teaching this course. So in this group, we have three group members. Firstly, it's me, Sidi HAJAR, and we have Izzati Husna and Shaza Akila. For introduction, let us know what is Diels-Alder reaction. So it is when a conjugated diene bonds, as you can see in the diagram, the left one, conjugated diene bonds, react with an alkene to produce a cyclohexene molecule. So the Diels-Alder reaction also can be said DAR, D-A-R, DAR. The reaction forms a cyclohexene ring, which is a six-membered cyclic compound, and the reaction is in a single step. So the process reaction occurs is known as cycloaddition. In the reaction, the electrons are transferred in a cyclic fashion between the diene and the alkene to form the cyclic structure. So in the reaction, heat is not required, but heating up the reaction will improve the yield. So this reaction is highly valued in organic synthesis because of its atom economy and specificity and ability to rapidly construct complex molecular framework. There are a few applications of DAR. Firstly, pharmaceutical intermediate. So the DAR is a useful method to obtain optically active intermediate that are useful for the synthesis of antiviral agent. Other than that, it's in use for producing natural product, which efficient in construction of complex polycyclic framework. And it also can be used for functional materials production. The reversible nature of DAR can be used for functional materials such as development of self-healing and recyclable polymer. So most of the DAR reaction exhibit slow reaction rate, and sometimes it requires harsh reaction condition because the electronic interaction between the diene and dienophile is weak. So to overcome this limitation, catalysis is usually used to enhance the reaction efficiency. Traditionally, Lewis acid catalysis activates the dienophile by lowering its LUMO energy, which leading to improved activity. But in recent study, base catalysis has recently emerged as an alternative approach where bases electrically activate the diene and enhance the reactivity through a different catalytic mechanism. So, base catalysts are such as triethylamine and pyridine.
The Diels-Alder reaction of two pyrone is an important reaction in organic synthesis. However, under uncatalyzed condition, this reaction is inherently slow, even when carried out at high temperatures. So in addition to slow kinetics, the reaction is commonly followed by a retro-Diels-Alder process, which results in carbon dioxide expulsion and decomposition of the desired product. So as a consequence, the uncatalyzed reaction shows low efficiency and poor selectivity, making it unsuitable for practical synthetic applications. Interestingly, experimental studies have shown that when a base is used as a catalyst, the Diels-Alder reaction can proceed rapidly at low temperature and without the retro-Diels-Alder side reactions. Despite this improvement, the fundamental mechanism by which bases catalyze the Diels-Alder reaction is still not fully understood. Therefore, the key problem addressed in the study is to understand how base catalysis accelerate the Diels-Alder reactions and suppresses decomposition pathways, especially in comparison to uncatalyzed and Lewis acid catalyzed systems. These knowledge gaps form the basis for investigating the mechanism of base-catalyzed Diels-Alder reactions.
Okay, next we move to the solution, base-catalyzed Diels-Alder reaction. So according to this case study that demonstrated that organic base such as triethylamine can effectively catalyze Diels-Alder reactions. So the mechanism of base catalysis, so the first is the base interact with the dienes, increasing its electron density. Next, this interaction rise up the HOMO energy of the diene. The HOMO-LUMO energy gap between the diene and dienophile is reduced. That make orbital overlap is improved, leading to lower activation energy. So this computational analysis show that the activation barriers is reduced by -10 compared to the uncatalyzed reactions. So the improvement is reaction proceed at lower temperature. Next is faster reaction rates, suppression of unwanted retro-Diels-Alder pathway, and more efficient formation of the desired cycloadduct. So for the conclusion, the summaries of finding found that the Diels-Alder reaction is a powerful synthetic tool, but it's often limited by slow kinetic under uncharacteristic condition. So the study by this demonstrate that base catalyst is an effective strategy to overcome this limitation. So the implication of the study, by electrical activating the die in enhancing orbital interaction, bases significantly lower the activation barriers, resulting in faster and more efficient Diels-Alder reaction under milder conditions. So this approach offers a promising alternative to low acid catalysis and expand the catalytic toolbox for cyclic additions chemistry.